Up to this point, we've discussed how a relation is a set of ordered pairs and different ways that we can represent relations. Before we move on to the next section, I just want to call your attention to the following. A line, and whenever you have a coordinate plane and you have a line on this coordinate plane, this line is composed of infinite points. So there are infinite points on this line. There are also infinite points in between 2 points. So if we talk about a relation is a set of ordered pairs. This means that if I have a graph of a continuous line, this is also a relation because a continuous line has infinite ordered pairs. But I'm not talking, even though the points are infinite, not all of the ordered pairs that exist are part of this relation. Only the points that fit on this line are part of this relation. So not this point isn't included in the relation, this point isn't included. Only the infinite points on the line are contained in this relation. So now we're going to go to domain and range of graphs. So whenever you guys look at a graph, I want you guys to think that microscopically, if we zoomed in enough, we would be able to see all of the infinite points that form this graph, all right? Another thing for you guys to pay attention to is the following. Whenever you have an arrow at the end of a line, this means that this line goes on and on and on forever, all right? Whereas if you have a point, for example, in this case over here, if you have a point, this means that the line stops. If you have a closed circle, if you have a filled-in point, a black point, this means that this point is included in your function. If you have an open circle, if your point is transparent or white, this means that this point is not included in this function or in this relation, all right? So whenever we had, let's go back a little bit, whenever we had ordered pairs, it was very, very easy to find the domain and range of my relation. But if I have a graph, this is not so easy anymore. So how are we going to find domain and range of graphs? So whenever you're going to do this, there are two strategies. Actually, there are several strategies. But let's start with the more conceptual one, and then we'll go on to some different options for you guys to find domain and range of graphs. The first one would be the following. You have to visualize that this graph is composed, this line is composed of infinite points. And notice that I'm not only marking the good, nice points, I'm marking randomly because you have infinite points on this line. Each of these points has an x-coordinate and a y-coordinate. So if we were to find all of the x-coordinates of all of the points, we would have our domain, right? Because the domain are all the x values. However, there are infinite points. How can we write the domain of infinite numbers? So what I want you to imagine is the following. This x value over here, this x value is somewhere over here. This one's over here. This one's over here. This one's over here. Over here. And this one is over here. This one's over here. And hopefully you guys can see that if this line goes on forever in both directions, this means that I'm going to have every single x value on the x-axis will be part of my domain. So my domain in this case will be all real numbers on the x-axis, of course, because the domain is only referring to the x-axis. Regarding the range, right? So the range would be all of the y values, which would be the projection of these points on my y-axis. So we would have all of these points over here being projected, and same thing over here, right? Being projected over here, over here, over here, over here, over here, over here, until this point over here. This would be the y value for that point. And you can also see that this function goes on forever. So this means that if it went on forever, all of these other points, we would have all of these other y values. However, not all y values are part of my domain, because my function has a minimum value over here at -2. So my range is going to be y is all the values above -2. Can it be equal to -2? Yes, it can, because -2, if you take a look at this over here, we don't see an open circle. If we don't see an open circle, this means that this is a closed circle, so -2 is included. So I want all the y values above -2 are part of my range. So how do I write this in mathematical language? My y value has to be greater than or equal to -2. And it's equal to because in this case, this minimum point is included in your final, in your graph. Let's move on to question number 2 now. Question number 2, same thing. You have to imagine that this circle is composed of infinite points. All right? And then each of these points has an x and a y coordinate. Let's take a look at how we could find all of the possible x coordinates for this function. So this x coordinate over here would be over here, this one would be over here, this one would be over here, this one would be over here, and hopefully you can see that we can't have all the x values being considered. We can only consider the values in between this number, which is -3, x equals -3, and x equals 3. So our domain is going to be x is in between -3 and 3. Now the question is, do I put the equal sign in my inequality? The answer is yes, because it's a closed circle. If we don't have an open circle, you assume it's a closed circle. So x can be in between or equal to -3 and 3, then this would be the domain of your function. Looking at the range would be all the possible y values, right? So this function over here, this y value is simply 3, and this one is -3, and hopefully you can see we're going to have all of the y values once again in between -3 and 3. So my range would be y is in between -3 and 3, and I put the equal to because it's included, right? This point of maximum and minimum are included in my function. Question number 3. Question number 3, I have a straight line. Once again, you have to imagine that it's made up of infinite points. Now imagine all of these points are going to merge into your x-axis, and hopefully you will see that we're going to have all of the x-axis being contemplated. This means that my domain is going to be all real numbers. The range is a little bit harder, but I think you guys will be able to figure it out. Remember, this goes on forever, right? This line goes on forever to the left and to the right. So the range is going to be these points merging into the y-axis. And it'll merge at a slower rate than the blue ones. This one's going to go over here, over here, over here, over here. But since it goes on forever, hopefully you guys will be able to see that in infinity, all of the y-axis will be contemplated. So my range is also going to be, in this case, all real numbers. Number 4. Number 4, once again, let's imagine our points. So I have my points over here. Imagine they're going to go to my x-axis. In this case, these would go down, and these would go up. So hopefully you can see that my domain is all real numbers. And same thing on my y-axis. This one is already here. These are going to move over here, move this way, and this way. And hopefully you can see that it goes on forever downwards, but it doesn't go on forever upwards. We have a point of maximum over here at 1, 2, 3, 4, 5. So this is going to be all the y values below 4. So my range is going to be y is less than or equal to, because it is included, to 4. Question number 5, I'm going to let you guys try it on your own and write the answer over here in the Edpuzzle video. If you need help, go back to the video and watch question number 2 again, because question number 5 is very similar to question number 2. Question number 6. Let's take a look at it right now. Once again, I'm going to draw my points, and I have to imagine them moving either to the x-axis or to the y-axis. So let's do that. I'm going to start with them moving to the x-axis. If I start moving them to the x-axis, these are going to go down over here to meet my x-axis. These are going to go up. These are already on the x-axis. These go down. This one's on the x-axis, and these go up. And hopefully you can see that since this function goes on forever, all of the x values are contemplated. So my domain are all real numbers. The y-axis, on the other hand, the y-axis, let's merge everybody onto the y-axis. So we have, you can see that it goes all the way up here. Then these guys also merge over here. This one too, this one and this one. These merge this way. And we keep on going all the way down. So all of my y values are being contemplated. So my range is also going to be all real numbers. Number 7. Number 7 is a little bit trickier. I'm going to draw my points so I have them as a reference. And let's get started moving all the points to the x-axis. And hopefully you'll see that I have all x values, because all of these points merge into the x-axis. So my domain is going to be all real numbers. My y values, on the other hand, these are going to merge over here. And so will all of these. So we don't have all the y values because there's a maximum point and a minimum point that my points can be at. My maximum point is going to be at 2. My minimum point is 1, 2, -3. So my range is going to be y is in between -3 and 2. Once again, notice that I put the equal sign because these points at the maximum and minimum are included. Also notice that whenever I'm writing this kind of inequality, guys, the smallest number is always to the left, and the arrows are always pointing to the left. If not, this inequality stops making sense if you mess this around. Number 8. I'm going to let you try number 8 on your own. If you need help, contact me and send me the answer in the Edpuzzle video.